Hi everybody, I had a student ask me about work session 16, question 19. So this question states a 0.135 molar solution of a weak base has a pH of 11.23. Determine the Kb for the base, the equilibrium constant for that, given the clues. And so, first things first is we recognize what's in my beaker. It's already told that it is a weak base. And so that's a big clue that I'll need a rice table. Also given the pH of the solution, I know from the pH I can find the pOH by taking 14 minus the pH. And when I do that, I get 2.77 for the pOH. I also know that pOH is equal to the negative log of the hydroxide ion concentration. So I could find the hydroxide concentration at equilibrium doing 10 to the negative pOH. And so when you plug in 2.77, you get the hydroxide ion concentration at equilibrium is equal to 1.69824 times 10 to the negative third molar. That's going to be a clue for us. Now, I think the trickiest part here is figuring out, well, what reaction do you write for the rice table, right? Because that has to be correct in order for everything else to fall into place. You can do two different reactions. You can do one where the base is neutral. Remember, with these equilibria, we're in the presence of water, weak acid or weak base. And so, remember, just use the definition. So, base is a proton acceptor. So, if it accepted a proton, it would be +1 charge, because originally it was neutral. And then if water donated a proton, then you would be left with the conjugate base of water, which is hydroxide. And we've talked about this in a previous video where I practiced a problem, and I said if you're doing weak base equilibria, one of the products should always be hydroxide, because that's the conjugate base of water. And then, when you have a weak base in water, water has to act as the acid, so that's why you need the conjugate base. Another reaction you could have written is that a lot of the bases in this chapter we're looking at end up with a negative charge. So you may be used to the HA being the weak acid, and then A minus being the conjugate base, and that's totally fine. And so if that were the case, the reaction would look something like this, where A minus would accept the hydrogen, and then it doesn't matter if you put the hydrogen in the front or in the back, since we're not actually drawing the structure and this is generic. But if it gained a proton, the A minus would turn neutral, so that's where you get the HA. And then once again, water had to donate a proton because it's acting as an acid, and that's where you end up with hydroxide. Alright, so just kind of giving you an idea of how to write the general reaction for a weak base. So initially it looks like we had a 0.135 molar, not including liquids or solids, and then 0 here. And then minus X for the reactants, plus X for the products. And then at equilibrium, 0.135 minus X, and then X and X. But we're asked to solve for Kb. Kb is what over what? Products of a reactant. Good. Now, it's really important, though, to recognize that you're like, okay, I don't know what this weak base is. I don't know the Kb at all, therefore, so I'm trying to solve for that. But we already had figured out the equilibrium concentration of hydroxide, right? From the fact that we knew our pH. So that is actually our X. From there, we also actually know this too, because all we have to do is plug in 0.135 minus X. So I have 1.69824 times 10 to the negative 3 molar squared over 0.135 minus our X that we solved for from the pH. And when we plug that into our calculator, you should get Kb is equal to 2.16 times 10 to the negative 5th. And, does that follow along with theory? Always kind of checking our work here. It does, in the sense that it's a really small value, which makes it mean that it favors reactants, right? And if it's a weak base, then we would expect the Kb to be small, right? So this kind of goes along what we would expect the Kb for a weak base. All right, if you have any questions, let me know. Good luck studying.